Good morning to all. Today I am going to present the topic on capacitor based energy storage, and the capacitor is a physical object that can store the electrical charge, and flash camera has a big capacitor in it, store up a bunch of charges, and the capacitor is basically having two plates that are separated by a distance d, and the two plates are which has charge q, positive q and negative q. These two plates have a voltage difference between them, that is q is directly proportional to the v. Then this diagram shows the initially uncharged capacitor, charging and fully charged. A capacitor consists of a pair of conductors separated by a dielectric insulator, C equal to epsilon A divided by D. Here epsilon is the permittivity, A is area, D is distance. Epsilon indicates how penetrable a substance is to an electric field. Electric charge is stored in the plates. A capacitor can become a charged. Then in this, storing energy in a capacitor is source in the figure. C equal to Q divided by V. C equal to Q divided by V. Then the unit of the capacitance are coulombs per voltage, C by V. 1 coulomb per voltage equal to 1 farad. Next, stored energy can be obtained by by integrating the previous equation, Q by C. Then we get these two equations. Then the graph shows the capacitor energy integral level. The graph is drawn between the time and voltage. Then next one is joules compared to the battery milliamp hours. Here 1 joule is 1 watt for 1 second, and the graph is shows for the joules compared with the battery level. Then next, the supercapacitor is one of the major type of the capacitor. The supercapacitor can be also called electric double layer capacitor, EDLC, or ultra capacitor. Everyone knows the capacitor can store energy, and the regular capacitor cannot discharge that energy in a slow manner, but the supercapacitor cannot only store the energy like conventional capacitor, but they can discharge the charge, their charge gradually, thus they work like a batteries. And then the next we will see the supercapacitor. Here the supercapacitor is classified into three types: double layer capacitor, pseudo capacitor, hybrid capacitor. The supercapacitor can charge and discharge indefinitely, no battery life problem. Supercapacitor can charge within seconds rather than the hours. Then this also classification of the super capacitor types with their families. Next one is basic design of the supercapacitor. Here two electrolytes are separated by a separator. These are called separator, sixth one, and these two are electrodes. These are connected to the end of the capacitors. When the power source is connected in that, then collector is second one is the collector. Electrode is third one. This is the electrode. Then the storage principle, double layer effect to the store electric energy. In this, when the voltage is applied to the here, when the voltage is applied to that electrode, these two ions are positive and negative ions are separated. Then the storage principle is based on this two principle: double layer capacitance, pseudo capacitance, and we can calculate it by these two principles the capacitance value. The ratio of the two storage principles can be depending upon these two factors like design of the electrodes and the composition of the electrolyte. And the pseudo capacitance can be as much of as 10 times of the double layer capacitance. And based on the electrode design, the supercapacitor is classified into three types: double layer capacitors, pseudo capacitors, hybrid capacitors. Then the double layer capacitors are with carbon electrodes or derivatives with the much higher electrostatic double layer capacitance than electrochemical pseudo capacitance. Next type pseudo capacitors with metal oxide or conducting polymer electrodes with a high amount of electrochemical pseudo capacitance. Third type is hybrid capacitors, capacitors with asymmetric electrodes, one of which exhibit mostly electrostatic and the other mostly electrochemical capacitance, such as lithium ion capacitors. Then next one is the electrostatic double layer capacitance. In this, the electrostatic storage device achieved by separation of the charge in a Helmholtz double layer at the interface between the surface of the conductive electrodes and electrolyte.
Start.
And then the separation of the charge is of the order of a few angstroms, like 0.3 to 0.8 nanometer, and much smaller than in conventional capacitor. Then next one is the electrostatic double layer capacitance. In this, the negative ions are separated in the electrode, and the positive ion is separated by the electrolyte. And simplified view of double layer of negative ions in the electrode and solvated positive ions in the liquid electrolyte separated by layer of polarized solvent molecules that are shown in this figure. In this, C is equal to epsilon A divided by D, and charging and discharging diagram is shown in this figure. Then next one is the electrochemical pseudo capacitance. In this, the simplified view of double layer with specifically observed ions which have submitted in this concept is shown in this figure, have submitted their charge to the electrode to explain the Faraday charge transfer of the pseudo capacitance. In this, the potential distribution is shown in below. The charge storage principles of the different capacitor types and their internal potential distribution is shown in below. Then behavior of the supercapacitors and batteries are during charging and discharging is shown in this curve. Then this table shows the electrical parameters of the supercapacitor series of different manufacturer. And next one is standards. The voltage behavior of the supercapacitors and batteries during discharging and charging is shown in this figure. Then next one is the application. The supercapacitor is widely used in many fields like general application, medical application, transport application. In general application, the supercapacitor is used in consumer electronics, buffer power, voltage stabilizer, energy harvesting, street light. And in transport application, aviation, military, likewise railways, buses, these are used in many ways. Then feature of the supercapacitor is these are the advantage and limitations: life cycle, high life cycle, quickly charge and discharge, operating capacitor temperature range, environment friendly. And limitations are low energy density, linear discharge voltage prevents use of the full energy spectrum, and cells have low voltages, high self discharge. Thank you.